Hi everybody, this is Richard from the SFU Satellite Design Team. In this video I'm just going to talk a little bit about HALCoGen and how to use it to configure the chip that we're using. So right now I'm in Code Composer Studio. This is where we edit our code. However, all of the initial drivers and setup code is generated by an app called HALCoGen that TI provides for us. So I'm on a Mac. So to actually run HALCoGen, I need to do it through Wine, which lets you run Windows apps on your Mac or on your Linux machine. So if you're on Windows, you can open HALCoGen by just finding the exe and clicking it, or it'll be in your start menu or whatever. Since I'm on a Mac, or you would do the same on Linux, open up Wine Staging. And this is assuming you've already followed the instructions for getting HALCoGen in the first place. I will post a link to those in the description. So Wine pops up a terminal for you. Now you need to CD to wherever HALCoGen is installed. So you're CDing to the directory that has halcogen.exe in it. So for me, that's my TI directory. So I'm in TI now. And then you're just going to type wine, HALCoGen, and hit enter, and it's going to start up HALCoGen. I'm just going to get out of full screen, and it will bring itself up. So there we go. Now I need to open one of the HALCoGen projects associated with SFU Satellite Design Club. So I'm going to go File, Open. I've already navigated to it for this example. And you can see we have two HALCoGen files in this repository. One is for the Launchpad, which has a TMS 570 LS 0432 on it. And we have OBC Prototype A, which has a more capable chip, the TMS 570 LS 0714. I'm going to open that one up. And let's say you needed to do some configuration. We'll go over how that works. So HALCoGen is going to pop open some windows, and they will turn into tabs very shortly. There we go. HALCoGen is finished opening. So now you can make your changes in HALCoGen. For example, the GIO tab is General Input Output. For example, on the OBC prototype, GIO A6 is connected to the debug LED. So let's say I wanted to make the initial output value to be 1 or on for the LED. I can make that change. Then you're going to hit File, Save, then File, Generate Code, and it will generate that for you. Then head back over to Code Composer, and it's asking me to reload, and I will say yes. If not, you are going to want to right-click on your project and click Refresh. I'll just do that anyway. Now, when you hit Build, you may have a build error come up. And this is because there is one file where we're using an include, or a define to change the configuration based on whichever board we have connected. So in this project, since I have the OBC Prototype A configuration, since that's the board I'm working on, what this ends up doing is it sets a symbol here, so just a hash define, SFUSat board to 1. If we switch over to the Launchpad configuration, it should say 0 in here somewhere. Doesn't seem to be loading, maybe because I haven't actively switched to it. Anyway, for the Launchpad configuration, it says 0 for SFUSat board. And this lets us control which code gets run by wrapping it in an if preprocessor directive. So the issue is HALCoGen, when it regenerates the rti.c file, it wipes out the hash ndif here. Now we've tried adding another user code begin, but it is replacing that too. So if this issue happens, you just need to add an ndif to the bottom line of rti.c. And if we save this and build it, it will build successfully. And my debugger is asking me if I want to re-upload, so I will do that. Apparently I now have a debugger issue. So I'm just going to hit reset a couple times. So I'm just going to reinitiate this debug session. That seems to have worked. Yeah, loading program. No worries, hit play, and then we get another printed message. So that worked fine. So we're all good here. Now I will just explain how we organize hardware in the repositories. So there are a lot of cases where you need to define some hardware-specific thing. For example, to connect to the real-time clock, we need to define which SPI port on the chip we're actually using. This differs between the Launchpad and between the OBC prototype. So we're going to take a look at how this works. So open up your OBC project, open up the SFUSat directory, and then go to SFU hardware defs. So again, it is using that that define that is created based on the project configuration. So settings for prototype A are here, and settings for the Launchpad are grayed out because that board is not configured. So this ensures that we're setting the correct hardware based on our configuration. And you can see for the RTC on this board, the prototype, we're using SPI port 4. And if we take a look at the Launchpad, we're using SPI 2. So that is how we deal with using different hardware, by breaking it out into defines in hardware defs. So for example, the RTC code, when it needs the SPI port, it will ask for RTC underscore whatever it needs, so that it is grabbing the value from hardware defs so that we can easily change it without having to pour through a bunch of code. So this allows us to easily change our hardware as well as manage different configurations of different processors. So that is all for this video. Thanks for watching, and if you have any questions, please do get in touch with me or Steven. Thanks for watching.